In this example, we're going to look at the definition of congruent triangles and use it to solve a problem. So if you look at this problem here, we have some given information, all this here, this big list. We have a picture of two triangles, and they're asking us at the bottom what we have to find. So there's three things. We have to find the measure of angle L. That's how you would read this. We want the distance from E to F. That's what this means. Right? What's the length of that segment? And we also want the measure of angle M. So let's find those three things, and we're done. So the first thing I'm going to start with is the given information. And here they tell me triangle DEF is congruent to triangle LMN. So if I look at the triangle, the orientation is kind of messed up. So what I want to do is rearrange it so that the two triangles look pretty much exactly the same, because again, they told us they're congruent. So I'm just going to redraw some triangles, and it doesn't matter really how they look as long as they look congruent. So it doesn't matter that, they're the exact same shape as what was given here. It's basically a way that we can see this more easily. So for instance, if I draw triangle DEF, I'm going to draw a triangle. I'm going to let this triangle represent my triangle DEF. And then I'm going to draw another triangle similar to that triangle. And this triangle is LMN. So LMN. So notice that when I drew these two triangles, when I labeled it, you have to label it in the same exact direction. So I labeled it starting at the top with D, and I went in a counterclockwise direction, the opposite directions of a clock. And over here, the same thing. I started at the top, and then I went in this direction, M, and then labeled this N. And we can see from our notation that D and L should be in the same spot, those two angles, which I can see is true. Angle E and angle M, E and M should also be in the same spot. We call that corresponding. And then the last set of angles, F and N, those should be corresponding, meaning they should be in the same spot. And you can see that that's true. So I'm going to put a little check to say it to myself that I know that that's correct so far. And again, these triangles don't look the same as these, but we do know that these two triangles should be congruent to each other. And the reason why I'm drawing it this way is so that when I label the information, I can see what matches up a little bit more easily compared to before, where things that you label might not match up. So the first thing they told me was the measure of angle L is represented by this expression, x plus 15. So for L, this angle, I'm going to put x plus 15. That's the measure. Again, this is just an expression, so don't worry about what it looks like. It just represents the measure of this angle. So if I did know what the value of x was, I would just substitute it, add 15, and I know how many degrees the measure of angle L is. Alright, so that's just an expression, and it represents this angle. So I'm going to put a check. I took care of that one. EF, without the bar above it, means that we're talking about the distance or the length of this segment. So EF, which is this segment here, the distance of this is going to be represented by 1.5y plus 1.3. So I'm going to write that here. Put a check mark here because I took care of that one. The measure of angle F is 5y. So F is here, so I put 5y degrees. And I didn't put the degree measure here, but that's fine. I'll put it here and here, so they both represent measures or degrees for the angle. The other one is NL. So the distance from N to L is 25.4. So NL is this segment, so I'll put the length of it right around the middle area. Put a check here. Oh, forgot to put a check for that one. And the distance from M to L is 53. So M to L is this one, so it's 53. So I'll put a check next to that. ED is 2x plus 3. Again, this is the length from E to D. So that's 2x plus 3. Put a check there. The measure of angle N is 120. So N is over here. So the measure of this angle, 120 degrees. And that's all taken care of. So I did all my given information. And now it says here we have to find these three things. So I'm going to look at pretty much what corresponds. And remember, the definition of congruent triangles means any corresponding angles will be congruent, meaning they will have the same measure. Same applies to the corresponding sides. sides in the same spots will have the same length. Again, that's what it means for two triangles to be congruent. So I'm going to use that to help me solve this. So if I look at, let's see, for the measure of angle L, that was the first thing they asked me to find. If I look at here, I mentioned it before, I need to know how much x is so that I can figure out the measure of this angle. So that first thing that lets me know is I have to find a relationship for x. So I can see in this angle corresponds with this angle, but for angle D, they didn't give me any information, so this is not helping me out. So I look at the picture and I say, okay, where else do I see an x? Well, if I look in the picture, I can see that the length of DE has an x in it, is an expression, 2x plus 3. And I know that DE, this length, is the same thing as LM because they're corresponding sides, they're in the same spot, so these two lengths should be equal to each other. In other words, I can say, because these are corresponding sides, I can say that DE, that segment, is congruent to segment LM. Again, these are corresponding sides, and by definition of congruent triangles, these two sides have to be congruent because they're corresponding. And the definition of congruent means, or for congruent segments, says that if two segments are congruent, I can say that they have the same length. So DE equals LM. And next, I can say the length of DE. Well, how long is DE? If I look at DE, that's 2x plus 3. We don't know the exact length, but it's represented by this expression, so I can substitute that in place of this. And then the length of segment LM, or the distance from LM, I can see is 53, so I can substitute that in place here. So far I can see that 2x plus 3 equals 53. So this becomes just a linear equation that we can solve. So I can subtract 3 to both sides. We get 2x equals 50, and then I can solve for x by dividing both sides by 2. So we get x equals 25. Now if I look at what they asked me to find, none of them say find x. So remember, just because you solve for something doesn't mean you're done. Always check, did you answer the question? So I can see here x is 25. And remember, if I wanted to know the measure of angle L, well, I just needed to know what x was. Well, since now I know how much x is, I can take this, substitute it in for that expression, and I can find the measure of the angle. So if I wanted to show the work for that, the measure of angle L is equal to x plus 15, that expression. And then I'm going to go now and substitute the value of x we found, which is 25. And when I simplify that, measure of angle L equals 25 plus 15, which is 40. Since that's the measure of an angle, I know it's 40 degrees. So this is one part of my work here. So that takes care of that part here. Now the other part, it says, what's the length of EF? If I look at the distance from E to F, is represented by this expression. So again, if I want to know this answer, you have to know how much y is. I have to find this value of y. So if I look at EF, this segment corresponds with this segment. But notice there's no length here. So that doesn't help me out. So again, if I need to use the value of y to solve for this distance, then I gotta find a relationship with y in another area. So if I scan through the whole problem, I can see angle F here. This angle is represented by an expression 5y. So there's the variable y in there. And I know that corresponds with angle N. And this actually has a value of 120 degrees, this measure. So I know that there's a relationship between this angle and this angle, and that is that angle F is congruent to angle N. And I know that because the definition of congruent triangles says corresponding angles, meaning the angles in the same spots, have to be congruent. They are congruent. That's the definition of congruent triangles. So if two angles are congruent, the definition of congruent angles means they will have the same measure. So the measure of angle F is equal to the measure of angle N. Now, what's the measure of angle F? If I look up here, is represented by 5y. So I can substitute that in there. What's the measure of angle N? Well, that's 120 degrees. And now I can see I have an equation with one variable, and I can actually solve this for y now. So all I have to do is just divide both sides by 5, and y equals 120 divided by 5, and that would give me 24. So that gives me the solution for this part. So that was my work for this section. And again, I solved for y. So actually, let me undo that. What I actually did was solve for y. So I almost made that mistake where I said that just because you solve for something doesn't mean you're done. We found what y is. But if you look here, it says find EF. So remember, we were trying to find EF originally, which means that we needed to know how much y was. So now that we found y, we can substitute that in place of that. So EF, that distance was represented by 1.5y plus 1.3. And then we get EF equals 1.5, and I substitute the value of y we found, which is 24, plus 1.3. And when we multiply this out, 1.5 times 24, I get 36 plus 13. And then we get EF equals 49. And remember, we were trying to find EF, so I know this here represents another solution. So I'm going to put a check here. I found the distance from E to F is 49. And then, let me erase this. Let me see, do I need the x equals 25? So we need the measure of angle M. So let me erase this to make a little more space. On your paper, you'd want to, carry on the work because you probably have more space than me. So now, if I look at the measure of angle M, we want to find that. So I look for the measure of angle M. Now here I can see that if I were to fix this here, this angle F, alright, we actually found the measure of that angle, or measure of angle L. If I look down here, remember we said that was 40 degrees. And we have this is 40, this is 120. Can we find the measure of angle M? Well, there's 3 angles in a triangle. We have 2 of them. If you have 2 angles, you're able to find the third angle. How? Well, because you have to recall that the sum of the measures in the angles of a triangle adds up to 180 degrees. In other words, all 3 angles, the measures, they're going to add up to 180 degrees. So the measure of angle M plus 40 degrees plus 120 degrees has to equal 180 degrees. Well, if I simplify, measure of angle M plus 160 degrees equals 180 degrees. And if I solve this equation for the measure of angle M, I subtract 160 to both sides. So I subtract that. And we get the measure of angle M equals 20 degrees. So this is the work to conclude my final answer here, which was find the measure of angle M. We found it. That was 20 degrees. And I can see 20 plus 40 is 60. 60 plus 120 is 180. So I know that that solution should be correct. So we were able to find the measures of these 2 angles, and we were able to find the distance of, or the length of that segment. So if you were to use this strategy, it would be very, I find it very useful to redraw the triangles like we did here. And once you redraw it, you could label everything you found and then try to find relationships between the variables that you're trying to find the value of. And then if you want, in the end, you could go back and label everything in your final solution.